Hey everyone, we're just going to take a look at the case with a suspected coronary obstruction risk and how to analyze that and what happened in the OR. So uh, the analysis we're going to show you is going to be based on this paper by Jaffer Khan from 2023, published in JACC Cardiovascular Interventions. And on this paper, the what they propose is that if the cusp height is higher than the coronary height, and the patient has either a calcium volume in the culprit cusp of 600 millimeter cube or greater, or a VTC of less than 4, that constitutes a risk for coronary obstruction. Okay, so we're going to pick up the analysis at this point. We've already created the virtual basal annular ring plane. I'm using a line segment 3D straight. We've got a coronary height and it's a bit on the low side. I'm going to use this line segment 3D straight to mark the ostium of the bottom of the ostium of the left main coronary artery. The number itself doesn't matter to us. We're minimizing this. I'm going to rotate my green plane, which is on my left main coronary artery, over to the left non-commissure. And I'm watching to see where that commissure tissue goes up and then comes back down again. And I think we've gone through it already. So you can see this little piece of black tissue over here. I suspect this is the commissure. I'm going to scroll up till I come to the point at which the cusps touch each other. And that's it. That's the commissure over there. I'm going to come down a little bit. And this is the point at which the commissure actually begins. And I'm just making a mental note of where that is. I'm also going to leave a line segment 3D straight marker at this point, making sure that line is sort of parallel to the pink, so there's no ambiguity when I'm looking at it again. I'm going to scroll back down to the virtual basal annular ring plane. I'm going to rotate around, going back through my left main ostium, over to the left-right commissure. This being a bicuspid valve, the left main commissure, sorry, the left-right commissure is going to be pretty low. And it's this thick black tissue over here. Um, and to check, I will scroll up, and you can see that is where the commissure is. It begins It begins at that level, right? That's where the cusp tissue touches each other and forms the commissure. So that's where it is. We're going to leave a line segment 3D straight marker at that point. Minimize this number because it doesn't mean anything. And I'm going to scroll back down to my virtual basal annular ring plane. Okay. Now I'm at this plane. I'm going to rotate back over to my left main coronary ostium. Okay. And I'm going to make a measurement or line running from the left non-commissure over to my left right commissure. These numbers so far don't mean anything. I'm going to minimize them, put them out of the way. And now I'm going to make a measurement from the cusp to the virtual basal annular ring plane of 8.3. I'm now going to label it as left cusp height less than left coronary height. So it's in the safe range, 8.3. We had a coronary height of 9.6. The next step is to delete the left non-commissure measurement, um, and also the left coronary ostium marker. And these measurements, we don't need this nor this. Okay, so we already have a left-right commissure marker. We want to find the right coronary artery height. So I'm rotating this anti-clockwise. My right coronary artery ostium is coming into view. I'm going to take a measurement. And I'm going to leave a 3D marker. Again, minimizing this number because it doesn't mean anything. And now I'm going to try and rotate this purple line over to my right non-commissure. Watching over here. It's potentially up here. It's a bit of a high commissure, but it looks like this is it. You can see the tissue up here. We're going to take a line segment 3D straight marking. And I'm going to rotate back around to the right coronary artery ostium. And scroll down. Now we're at the virtual basal annular ring plane. Sorry, I'm minimizing this marker, which I forgot to do earlier. And I'm going to take draw a line from my right non-commissure to the right left commissure. And we can see that it is higher than the RCA ostium. I'm going to take a measurement over here. It's 9.3. And so I can make mark a label here saying R right cusp greater than right coronary height. Okay, right cusp height greater than right coronary height. And I'm going to label this, and obviously I would take images. So this is now constitutes the first part of the coronary obstruction risk. Okay, so the next thing we got to get is a VTC for this valve. The only issue is that once we scroll up, we can see the virtual valve is not coaxial to the aortic root. So we've got to reposition this virtual valve in a coaxial fashion to get a true VTC, or at least a simulated VTC of how this valve might end up inside this root. Obviously, this is all based on best guess and our simulation. It is may not be exactly what's going to happen in real life. But first of all, we've got to extract that S323. So we go to embedded geometry, going to remove our S323, switch back to TAVR. And now we're going to delete our virtual basal annular ring plane and our original RCA measurement. Okay, so our green line here, we want this to run as centroid as possible through the STJ, center of this STJ here, and then center it on the STJ. I'm going to move this down a little bit because I can't see my STJ clearly. Center it in the STJ over here as well. Now I'm going to rotate this green line back over to my left main, and I want this blue line to be centered in the STJ as well, to give me that coaxial orientation of the valve. I'm going to scroll up now and find the lowest nadir, and just as I lose that, um, I'm going to call that the sort of the coaxial annulus, if you will. I'm going to go over to my annulus tool over here, erase it here, and then restart to create that coaxial annulus and do some minor editing of that. Now that's been edited, I'm going to re-embed an S3 Ultra 23 for this 4.08 square centimeter annulus. Obviously, the annulus at the coaxial plane is not going to be that 4.08. It just needs to be coaxial to the root. I'm going to pull this valve down by 2.7 millimeters, which is 15% below the virtual basal annular ring plane. I'm going to finalize it. I don't need to know what my left main VTC is because we already know that the cusp height was less than the coronary height for the left main coronary artery. We're going to look at this RCA very closely though, because of the cusp height being higher than my coronary height. So I'm going to scroll down until my pink line is in the center of the ostium of the RCA. And at this point, I want to make sure that I'm centered here, my blue line centered here. I might find the one where I can see a waist, and I just might make a marker here, for example, and try and get as accurate a VTC as possible using my line segment 3D straight. So I'm gonna use this pink as my guide, and I'm gonna drop this measurement here as my VTC. So I'm getting a 3.07 for the VTC. Hold this over here. And next we have to look at the cusp calcium. Not that it matters. This would be enough to say that this right coronary artery is at risk. So I know my calcium volume is 1100 millimeter cube from performing a calcium score on the 64 slice or 2.5 millimeter section calcium score. I'm now going to keep that number on my Excel sheet over here. I have loaded my 256 images or 0.625 millimeter calcium score into my TAVI1 workflow. I'm going to find the aortic valvular calcification over here. As you know, when we saw earlier the annulus, there was no landing zone calcification. So I'm just going to be focused on getting to my the plane of the calcification over here. I link to 3D. I want to maybe clear up some of this other um, streak that's around my valve. so I can see it more clearly. Okay, so now we've cleaned up the virtual VRT images or VRT from all the non-aortic valvular material. We can see the calcification of the left, the right, and the non-coronary cusps. I'm going to create a polygon just to guide me as I um, sorry, draw this calcium in and get a differential for my non on my left and my right. There is no median raphe calcification in this case. Now, what I want to do is switch back to MPR and start drawing some of this in. So I go to measurements, I pick calcium score. I'm going to show you my calcium defaults over here. That's 200 for min and 2400 for max, and that works on a calcium score acquisition. I save the longest straight line for the computer to draw itself, if I can, or remember to do it. I'm going to move this off screen for now. And I'm going to pick right cusp now. And maybe draw this. And over here. And now my non. And let go. So now I can hit complete. I can pull these numbers up. And I can punch these numbers into my calculator. So left is 94. Oh, sorry. I should be looking at the volume, right? So left is 71. Right cusp is 125. 125. Non-coronary cusp is 579. And I can punch in 775 into our totals over here. I'm going to share my screen with you over here. So now you can see 71, 125, 579, and 775. Median raphe is 0. And I can see my breakdown 9, 16, 75. More importantly, I can see the actual cusp is for the right cusp is 177. So it's nowhere near the 600 millimeter cube cutoff that I need to trigger that as a risk factor for coronary obstruction. Anyway, this is more for educational purposes. What matters in this case is obviously the VTC, because that is already proven to be less than 4 millimeters. So we're going to return to the multivariate prediction model. We now know that our right cusp height is higher than our right coronary height. And of the two following components, we have one of them, which is our VTC is less than 4 millimeters. Although our cusp, the culprit cusp calcium volume is less than 600, it is not needed to create to fulfill this multivariate prediction model and say that there is coronary obstruction risk. So the TAVI team took our concern seriously. They decided to do upfront protection of the right coronary artery with the guideliner and stent. You can see here the root injection, followed by nominal inflation of an S3 Ultra 23 valve, and immediately the RCA occluded, and there was ST elevation. So now you can see chimney stenting of the RCA, followed by selective injection of the RCA demonstrating flow being restored.